Hello there. My name remains Ajiboye Oladapo, and I welcome you to the Global Tutor virtual class. I want us to take a series on chemistry calculations, and I'll be starting the series today with masses of elements, molecules, and compounds. If you follow this channel, it will help you a lot to understand a lot about chemistry calculation. Shall we begin? The first that you need to know is what we call relative atomic mass, which we normally use an acronym for RAM, R-A-M, RAM, meaning relative atomic mass. What is relative atomic mass? A relative atomic mass is defined as the number of times the average mass of 1/12 the mass of one atom of carbon-12 isotope. Now that is English. But what we're simply saying in mathematical way is that relative atomic mass of an element equals average mass of one atom of the element over 1/12 the mass of one atom of carbon-12 isotope. Now, example, if you look at it, the relative atomic mass of hydrogen is 1. The relative atomic mass of carbon is 12. The relative atomic mass of nitrogen is 14. The relative atomic mass of oxygen is 16, and so on. One thing you need to note is this: relative atomic mass does not have any unit. It has no unit. You may ask, why does relative atomic mass not have a unit? It is because it is a ratio. Relative atomic mass is showing the ratio between the average mass of one atom of the element and that of 1/12 mass of one atom of carbon-12. So because it is a ratio, it has no unit. Now, if you look at the relative atomic mass of most elements, it is not whole number. Why is it not whole number? It is because existence of a phenomenon called isotopy. Isotopy is a topic on its own, and I promise you, if you follow this channel, we will deal with isotopy as a topic on its own. But just know that relative atomic mass of most elements are not whole number because of the phenomenon called isotopy. Now, the next we have is relative molecular mass, RMM, relative molecular mass. Now, the relative molecular mass for an element or a compound is defined as the number of times the average mass of one molecule of it is heavier than 1/12 the mass of one atom of carbon-12 isotope. Now, how do we calculate the relative molecular mass? We calculate the relative molecular mass by taking the addition of all the relative atomic mass of the atoms in one molecule of that chemical substance that we are considering. Meaning, you're going to add the relative atomic mass of all the atoms in the molecule. Note, it has no unit also. So, the unit of relative atomic mass is no units. The next we have, let's take example on how we can calculate the relative molecular mass of some compounds. Example number 1, we want to calculate the relative molecular mass of CaCO3, calcium triosocarbonate 4. How do we calculate that? We just define relative molecular mass as taking the summation of all the relative atomic masses of the atoms involved in one molecule of the compound. It means therefore that we will say the relative atomic mass of calcium, which is 40, plus the relative atomic mass of carbon, which is 12, plus the relative atomic mass of oxygen. But here, there are 3 atoms of oxygen. So you have 16 times 3. Now, 16 times 3 will give us 48. So when you add 40 plus 12 plus 48, you're going to have 100. Remember, relative molecular mass has no unit. So you just leave it like that, 100. That is example number 1. Example 2. Let's calculate the relative molecular mass of water, H2O. Now, the relative atomic mass of hydrogen is 1. There are 2 atoms of hydrogen here. So 1 times 2 plus the relative atomic mass of oxygen, which is 16. So we have 1 times 2. That will give me 2 plus 16. So 2 plus 16 will give me 18. No unit. So the relative molecular mass of H2O, water, is 18. Then number 3. We want to see how to calculate the relative molecular mass of H2SO4, hydrogen tetraoxosulfate 6. Now, how do we do that? There are 2 atoms of hydrogen. So we have 1 times 2 plus the relative atomic mass of sulfur, which is 32, plus there are 4 atoms of oxygen here. So we have 16 times 4. 16 is the relative atomic mass of oxygen. So if we do that, 1 times 2 will be 2. 16 times 4 will be 64. So we have 2 plus 32 plus 64 giving us 98. Meaning the relative molecular mass of H2SO4 is 98. Then the last example is NaCl. Now this is sodium and this is chlorine. So what is the relative atomic mass of sodium? 23. What is the relative atomic mass of chlorine? 35.5. So if you do the arithmetics, you're going to have 58.5. Meaning the relative molecular mass of NaCl, sodium chloride, is 58.5. Those are examples under relative molecular mass. Next, we have mole. 1 mole of a substance is the amount containing as many elementary entities as the number of atoms in exactly 12 grams of carbon-12 isotope. Now, what are we saying? We are saying the 1 mole of a chemical substance is that quantity of it that contain as many elementary entities as the same as 12 grams of carbon-12 isotope. Now, we can write mole also as MOL. Instead of writing MOLE, you can also write it as MOL. They are the same thing in chemistry. Now, what do we call elementary entities? Now, elementary entities may be atoms, maybe molecules, maybe ions, maybe electron, and any other particles. In chemistry, anytime you see elementary entities, your mind can go to atoms, it can go to molecules, it can go to ions, it can go to electron, and any other particles. That is what we call mole. Then we have what we call Avogadro's number. What is Avogadro's number? Now, this number was discovered experimentally. And during the experiment, it was discovered that 1 mole of any chemical substance contains 6.02 times 10 raised to the power 23 entities. Remember, we just talked about elementary entities in the last couple of minutes. Now, so it means in every 1 mole of a chemical substance, we have 6.02 times 10 raised to the power 23 entities. Now, that 6.02 times 10 raised to the power 23 is what we refer to as Avogadro's number. The next, we have molar mass. Now, molar mass is defined as the number of 1 mole of a substance expressed in grams. It has a unit, gram per mole. Now, See, the simple truth is this: molar mass and relative molecular mass are the same. The difference between them is that relative molecular mass has no unit, while molar mass has a unit, which is gram per mole. Now, if we go back to the examples we did under relative molecular mass, we calculated the relative molecular mass of CaCO3 as 100. Now, if you want to calculate its molar mass, it will still be 100, but the difference will be 100 gram per mole. The same goes for water. It will be 18 grams per mole. The same goes for H2SO4. It will be 98 gram per mole. And the same goes for NaCl. It will be 58.5 gram per mole. So what differentiates molar mass and relative molecular mass is the unit. Relative molecular mass has no unit. Molar mass has a unit, which is gram per mole. Now, let's talk about percentage composition. Now, percentage composition is the percentage by mass of an element in a compound. Meaning, every element has its percentage in the compound. But how do we calculate it mathematically? We take the mass of the element over the molar mass of the compound and we multiply it by 100%. I'll use example to prove this formula to you. Let's see. We want to see in H2O, we want to calculate the percentage of hydrogen in H2O. So how do we do that? The mass of hydrogen over the molar mass of water, H2O, times 100%. So in H2O, we have 2 atoms of hydrogen. So we have 1 times 2 over the molar mass of H2O is 18. We just did that few minutes ago. Then multiply by 100%. So we have 1 times 2, 2. 2 times 100, that is 200 over 18. If you do the calculation, you're going to have 11.11%. Meaning in a molecule of water, there are 11.11% of hydrogen. We'll solve more questions. Now, in my next video, I'll be taking more examples and I'll also be taking past questions from WAEC, from NECO, and from UTME. All you need to do is to like this video, follow our channel, and share this video. We will see some other time. Success.